Welcome. In this video we'll be graphing trigonometric functions, sine part 2. Example. Use a graph of the parent function shown below to sketch the stated function using radians. Also, find the amplitude and period of the function. The function we want to graph is y equals sine of theta minus 1. And we're provided with the graph of the parent function, namely y equals sine of theta. So what we're going to do here is to generate a table of values. So let's start by saying what are the possible values for theta for our particular table. So we're going to take theta to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, what we're interested in is y is equal to sine of theta minus 1. So let's go ahead and substitute in the values into this particular function. So we have y is equal to sine of 0 minus 1. Then you have y is equal to sine of pi over 2 minus 1. Y is equal to sine of pi minus 1. Y equals to sine of 3 pi over 2 minus 1. And y is equal to sine of 2 pi minus 1. So let's see what are the output values here. Now, based on the graph of the parent function, we can extract some values here. So sine of 0 has an output value of 0. So we have 0 minus 1, which will give you negative 1. Then sine of pi over 2. Pi over 2, the output gives you 1, so we have 1 minus 1, which gives you 0. The next one we have sine of pi. Sine of pi, again, gives you an output of 0. So you have 0 minus 1 here, gives you negative 1. Then you come up to 3 pi over 2. Sine of 3 pi over 2 is negative 1, so we have negative 1 here. Minus 1 gives you negative 2. And lastly, you come back to sine of 2 pi, which is 0. So you have 0 minus 1 gives you negative 1. So what we're going to do is to plot these points, the points with the given coordinates, 0, negative 1, pi over 2, 0, pi, negative 1, 3 pi over 2, negative 2, and 2 pi, negative 1. So let's go ahead and plot those points here. So we have 0, negative 1, pi over 2, 0, pi, negative 1. Then you have 3 pi over 2, negative 2. And then you have 2 pi, negative 1. And then we'll just connect these points carefully to generate our function y equals sine of theta minus 1. Okay, so notice that your parent function got shifted 1 unit down. Okay, so y equals a sine of theta minus 1 means that you had a vertical shift of sine of theta 1 unit down. Okay. In terms of the amplitude, what we can do is, we can trace the midline here. And we can see that the distance from that midline to the minimum happens to be 1. Or from that midline to the maximum, it's still 1. So we can say that the amplitude is 1. Another way to figure out the amplitude is to say, well, amplitude is equal to the absolute value of the coefficient of sine. So notice that here you have an implicit 1. So we have absolute value of 1, that is equal to 1. And in terms of the period, okay, one finds the period by taking the period of sine of theta, which is 2 pi, and dividing that by the absolute value of the coefficient of theta. And the coefficient of theta here is also an implicit 1. So we have 2 pi divided by the absolute value of 1, which is the same as 2 pi divided by 1, or simply 2 pi. So the period of y equals sine of theta minus 1, it's still 2 pi radians. So that concludes this video on how to graph trigonometric functions assigned part 2. Thank you for watching and have a wonderful day.